tutorial, we're going to look at a one-way analysis of variance, also known as a one-way ANOVA. And here we have two variables, a continuous dependent variable, anxiety, and it's got a continuous scoring system. Right now you can see that the lowest level of anxiety, or the lowest score in anxiety, is a 1, and the highest appears to be an 11. And then we have a grouping variable, let's just say political affiliation. You can see here, Group 1 refers to liberal, Group 2 refers to very liberal, Group 3 refers to conservative, and Group 4 is very conservative. And what we want to do is we want to find out if there are some statistically significant differences in anxiety of the presidential administration based on perhaps this political affiliation category. So, at the time of this video or tutorial, President Donald Trump is the president, and so maybe we would see significant differences based on political affiliation, on in terms of anxiety that individuals feel. And so this is just made-up data. It's a small data set. You would never run a one-way analysis of variance with just 20 individuals and 5 in each group. That's way too small. But for teaching purposes, this is a good heuristic example. So the first thing we want to do is we want to look at our model assumptions. And so I go to Analyze, Descriptive Statistics, and Explore. And remember that we want to see if our distribution, if our groups are normally distributed. So I put that here, and I'm going to put my dependent variable here, and I'm going to click on plots. Some people like to look at stem and leaf plots. They're nice. I don't need them, but I'm going to look at them. Sometimes we look at normality plots when we have larger sample sizes. I like to look at the box plots. So from here, we're going to go to Continue, and we're going to hit OK. And you can see here, I've got a lot of descriptive statistics for each of my 4 groups. And I can look at my normality assumption here, the Shapiro-Wilk statistic. I use this when I have small sample sizes, say under 30. I like to use the Shapiro-Wilk statistic. And you can see all of these are greater than 0.05. There is no statistically significant deviation from a normal distribution and my group distribution. So again, these are very small samples. And we can look at the QQ plots. These aren't going to be very informative. I would only want to look at these when I have large data sets and we want to see the data points close to the line. So we also get detrended data. I don't find this very helpful. I usually take this portion here and I go to Edit and I delete the detrended QQ plots because I don't find them very helpful. And then here are some examples of what these look like in terms of box plots. Again, the distributions don't look very good because we have very small sample sizes. When you have small sample sizes, graphical distributions aren't the most accurate. But you can see Group 1 is a fairly normal distribution. Group 2 seems to have an outlier. Group 3 looks fairly normal. Group 4 appears to be skewed. And so you can see that here. Not severely skewed, but definitely you got a data point that seems to be pulling the distribution a little bit. Though the median is right near the middle of the box, so that's a good thing. So just some descriptive data. I would say that because of our Shapiro-Wilk statistic with a small data set, we've met our normality assumption. So now let's look at homogeneity of variance in our ANOVA results. And so we go to Analyze, General Linear Model, Univariate, and I have anxiety I put over here. So normally it's going to look like this. And then I take anxiety and I put it in my dependent variable, and I take my grouping variable and I put it here under fixed factors. This is my independent variable right here. And then I go and I click on options, and I like to look at descriptive statistics, estimates of effect size, and the homogeneity test. I always click on those. I hit continue, and then I hit OK. And so here you can see the sample size of each group. You can see the means and standard deviations of each group. You can see the homogeneity of variance test. I always look at based on the mean and we can see that p is greater than 0.05. My variances are not statistically significantly different from each other, so I met this assumption. There are no differences. And then I look at my ANOVA results, and I go, okay, let's take a look here. F of 316 equals 11.49. P is less than 0.001. And I'm accounting for about 68% of the variance in the model. So group differences account for about 68% of the difference in the model. This is a really, really large effect. Political affiliation is definitely impacting anxiety. And so now we can look and investigate how this is playing out. And so we're going to run our ANOVA again. But this time, we're going to ask for a post hoc test because we have significant differences. So I move my grouping variable over here, and I click on the Tukey. Post hoc test, I hit continue, and OK. And it reruns my analysis, but then it gives me these multiple comparisons. Now, SPSS does something stupid. It compares each group to the other group twice. So you see liberal to very liberal, liberal to conservative, but then you see conservative to liberal, you can see very liberal to liberal, and so each one is twice. I don't need to report these twice. I don't want to report liberal to very liberal and then very liberal to liberal. So that's the same comparison. So don't worry about that. Just each group comparison once. And so with 4 groups, you're going to have 6 pairwise comparisons. And so I take, and so I can see that looking at 0.05 as my level of significance, I can see there's a difference between liberal and very conservative. There's a difference between very liberal and very conservative. There's a difference between conservative and very conservative. And so everything different from very conservative, didn't it? And then of course there's a difference between very conservative and very liberal. So, and you can look at the confidence intervals based on the significance if you wish. So, but that, you'll use 0.05 to determine if there are statistically significant differences in your pairwise comparisons. And you can then use these values to compute the Cohen's d. So I like to use the mean differences and then divide that. And because I have homogeneity, because my homogeneity of variance assumption is met, I can just take this 3.325 and square root that value, and that becomes my denominator. And I use these mean differences as my numerator, and that's a good rough estimate to compute my Cohen's d, a nice little shortcut when my homogeneity of variance assumption is met. And so I'm able to examine practical significance that way. So when it comes time to write up my results, we can begin to see where the numbers come from. And so I simply state a one-way analysis of variance was conducted to explore group differences, maybe political affiliation based on an anxiety score. An alpha level of 0.05 was utilized. Descriptive statistics are in Table 1. And so you can see I'm going to have Table 1 here and have the sample size, the mean, and standard deviation, and it's just going to come right from here. Now, SPSS does not give you tables in APA style, so you have to create those. But this is where the data is coming from. And then I say all groups were normally distributed. That's because my normality assumption for the Shapiro-Wilk statistic was met. And that's right up here. And all these values are greater than 0.05. All right. Variances were homogeneous, so I met my HOV assumption. You can see that right here. F of 316 equals 1.367. P equals 0.289. It's right here. Statistically significant differences were evident among the groups. F of 316, see here's my grouping variable, equals 11.49. P is less than 0.001. A large effect size was noted. Eta squared equals 0.68. indicative of a strong degree of practical significance. And then I can run my power analysis, and there's a separate tutorial I have to help you understand the power analysis. In order to investigate statistically significant differences between the groups, a Tukey post hoc analysis was conducted. And again, you can see where those statistically significant differences are. You can see the mean differences and where those values come from. All right, where the p-value was for each pairwise comparison. And I denote where the statistical significance was. And I compute an effect size for each pairwise comparison. So that concludes our tutorial for Way ANOVA using SPSS.